All right, I think I'm going to get started. I am here to introduce your speaker for today. I'm an intern at the American Institute of Mathematics, and I'm just helping out as tech support. But our presenter today is Chris Bolognese, and he is a teacher of math and computer science at Columbus Academy. And he's also been with the started the Columbus Math Teacher Circle, and he's been there for about 8 years, which is wild. But yeah, without further ado, Chris, take it away.
There's the mic. So I'm sporting my shirt. Hopefully you're wearing your own swag. Yeah, thanks for the introduction. I felt like I was backstage or something. So that's awesome. So it's great to see all of you. It looks like we have a good sizable crew of about 20. That's fantastic. It looks like we are well represented across the US of A and elsewhere. Nice. We've got India represented. That's fantastic. What time is it right now in India? Or what day is it? That shows my lack of geography. So yeah, I teach high school math and computer science. I teach at Columbus Academy, an independent school that starts with 3-year-old students all the way up to grade 12. And I'm excited for the school year to begin, though also faced with the same uncertainty that you probably are, whether you teach middle school, elementary school, high school, higher ed. Wow, 11:30 p.m. Okay, nice. So I'm really excited about this topic. Myself and another co-presenter actually wrote up a bit about this from our exploration in our circle. And it's in the MT Circular newsletter. That's the newsletter that AIM puts out, I think, quarterly. So if you search my name and MTC, I'm sure you'll find it somewhere. And I'm not going to share these slides just yet, but at the end, I'll gladly share how you can access this. There's not much to the slides because we're going to be exploring a lot. And if you use Twitter, give me a shout on Twitter. I'd love to connect with you. Okay, so I'm going to navigate 2 screens. I'm not cool enough to have 2 different monitors. So we're going to play with perfect rulers today. Tell me in the chat what you think that means, just from the title. Or maybe you read a little bio about the session we're going to do. What do you think makes a ruler perfect? Any conjectures? Extremely accurate, yeah, right. So we can measure to any like decimal place of accuracy. That's a cool idea. Is that precision or accuracy? Easy to use, that's nice. I'm not the most handy person, so something that doesn't come with lots of instructions. Maybe a way that we can measure lots of things because of lots of divisors or markings. I'm seeing someone mention. Yeah, and Leslie is well researched. Okay, so a title, maybe the word perfect is what we're going to try to figure out, right? So I thought we're thinking so much about rulers and things. This is a bit playful, of course, right? When do you think the first ruler was made? I did not know this when I was making some slides, and I thought that was an interesting question. I don't know if this is worthwhile to put you in breakout groups just yet, but any conjectures in the chat? When do you think the first ruler was made, at least from our estimates? Don't go Googling it. It definitely seems like something that shouldn't be relatively modern, right? And is it, before the Greeks, if you will? Okay, so there's some good guesses. What do you think it was made of? Calvin thinks stone. That's a cool idea. Bone, okay. Strings, interesting. Yeah, good point, Calvin. I guess the first ruler we have record of. Yeah, that's a great point, right? Maybe what do you consider a ruler? Like, is someone doing this? Is that a ruler? So these are up to interpretation, of course. Now, an inch, right, should be well defined. How old is that? Any guesses as to where the inch originates from? Calvin, you know a lot about measurement, it looks like. Just a raw estimate. Is it 50 years old? Is it 500 years old? Is it 1,000 years old? I read that only 3 countries, I believe, have not accepted the metric system, the US being one of them. Okay, so this isn't the point of the talk, right? It's not a history of measurement, but, and this isn't a talk, although I'm talking. From what I found, supposedly the first ruler was 2650 BC, so, 4,000 plus years ago. Almost 5,000, I suppose. And it's made out of copper, which is interesting, right? That seems like a precious metal. So maybe they really valued this thing. And this inch has quite an interesting saga. I guess from what I read, it dates back to 1150. And originally it was just based on the thumbnail. And to make it more, this is interesting, to make it more precise, they would find someone with a short thumbnail, medium, and large, and then average the 3. So that doesn't seem very, very well defined, right? So then later, they started using barley and placing 3 pieces of barley end to end. Seems somewhat arbitrary for something that should be so well defined. Okay, so yeah, crowdsourcing, nice. Okay, so that aside, right? Not to be political here with using inches. Let's just use units, whatever a unit is. So here's a pretty, hopefully straightforward ruler that I have. And this will get us thinking about what we mean by perfect. So imagine I gave you this device. What lengths could you measure? In units, of course, right? So I invite you to think about that. What are possible lengths that you can measure? If you have an idea, you're welcome to record. And if you have a question, feel free to ask, but that doesn't mean I have to have the answer, right? Part of this will be us making agreed upon assumptions. So what lengths could you measure? Like how many units could you measure? Just from this device alone. Hopefully my slides are updating. I was in another session and they were advancing for them, but not me. So if that's an issue for you, feel free to refresh your page. Okay, so looking at the chat, it looks like folks started by saying what objects they could measure. That's interesting. I mean, do we agree we could measure something of 1 unit length? Right, we naturally start at the end and go to where the 1 is, and that length is 1 unit. And then we could do 2 and 3 and 4 and 5, right? Start at the end and go to whatever marking is well defined. And since we know it's 6 units, of course, we could do something of length 6 units, right? It's the whole scope of the ruler. Now, folks are asking great questions. I love how you're thinking outside the box. Could I measure something of length 7? And I saw some asking, well, you know, how often could we like repeat the use of this device? So of course, right, we could mark from beginning to end of the ruler. We know that's 6. And then as long as we feel comfortable continuing that in like a collinear way, we could measure 1 more to get 7. So are we allowing sliding, basically? And I want to say no, right? I think if I really want to be sure I can measure 7, I need a longer ruler. So can we at least agree that you can measure 1, 2, 3, 4, 5, and 6? And 0, right? I guess do nothing, and we can measure 0 units. And I loved all the ideas that you were shouting out of, you know, we could estimate the midpoint and maybe get halves. One individual of mine in our session said, what about the like height of the ruler, right? Or even the thickness, maybe you could use those, but we don't really know how tall or how thick it is, right? So hopefully this is obvious, right? We can measure 0, 1, 2, 3, 4, 5, and 6 with a 6-unit ruler. How do we know 5 is 1 unit from the right end? Great question, because I'm telling you it's a 6-unit ruler. So while there's not a mark where 6 is at the right end, you can believe me that it's 6 units long, which then would require the 5 is 1 unit away from the end, right? Okay, so this ruler can measure 0, 1, 2, 3, 4, 5, and 6, right? What if we deleted some marks? Could I get by with less markings? Maybe those markings are made out of, you know, $1 million ink or something, or gold. The less marks, the less expensive. And if I could have a ruler with less marks that still can measure all the same lengths that we could have with this ruler, I would say that's better, right? That's optimizing our marking system. So I'm going to put you, well, I'm going to get out of presentation mode. If you've never used Remo, it's like a food court. And you can pick a table where you sit. There's even an upstairs floor, but let's not go up there because we don't have enough people for that. And I'm going to present a little task for you that I want you to talk through. And I'll give you about 10 minutes to do so. And then we'll come together and share out what we found. Okay, I'm going to try to visit every table. I encourage you try to be at a table with a few folks you don't know, and of course you should start by introducing yourself. What do you teach? How are things going where you're located? Because these are very uncertain times, right? Lean on one another for help. And I would ask that you have maybe at least 3 people per table. That way you can have a breadth of perspectives. So here's what I'd like for you to think about now. So I took our 6-unit ruler and just erased away some markings. And I had ruler A, and I'd encourage you to write this down because you won't be able to see my slides once I stop presenting. Ruler A, you're told, is a 6-unit ruler, but now it has marks at 1, 3, and 5. And that's it. And of course, you get 0 and 6 for free, right? Ruler B, I kept the marks at 2, 3, and 5. Again, you know it's a 6-unit ruler. So my ultimate question for you, are these rulers just as good as the one with every unit marking, 1, 2, 3, 4, and 5? Okay? So tell me got it when you've recorded these in the chat. Just let me know that you have these written down. One, 3, 5, 2, 3, 5, exactly. 2, 3, 5 are Fibonacci numbers, and 1, 3, 5 are consecutive odds. I didn't even noticed that. And I see some questions in the chat. I'd rather you negotiate those in your group, and then that'll have a chance to share maybe different definitions when we come back together, okay? So right now, it's somewhat of an ambiguous question, and that gives you more space to explore. If you have 135 and 235, can you still measure all the lengths 1, 2, 3, 4, 5, 6, and 0? Okay, so find a table. Be sure you introduce yourselves, and we'll come back together. We'll see where we are in 8 to 10 minutes. I'll give you a warning as well, just so it's not, you're caught off guard. Okay, have fun.
Well, I think ruler B will measure everything from 0 to 6.
Yeah.
I don't think it'll do 4.
If you start at this end,
Oh,
1, 2, 3, 4.
I didn't think about that part. You're right. Yes. And A will do all of them too.
How do you do?
You can't do
Yeah,
2
that's
with
2.
A.
Yeah, 1 to 3 or 3 to 5.
You can do 1 to 1 to 3. But you can't do 4 with A.
You can do 1 to 5, get you 4.
Oh, you can do
We can
1.
do 4
You can.
With
You're right.
A?
with
With
A.
A.
Yeah,
Yeah.
1.
1 to
1.
5.
Yeah.
Oh yeah. Yeah.
Oh no, that was
Okay.
quick.
Oh, we got it. So both of them are useful.
But are we allowed to use both rulers simultaneously?
I don't think so.
No,
I
no,
think you just get 1,
But both rulers will measure everything from 0 to 6.
just like the original one did.
2,
Using less very
3,
expensive.
4, 5. Yeah. Yes.
Great.
Or table 9.
Because I was even gonna say like just even 1, 2, and 3 can give you 1, 2, 3 could give you everything, right? 1, 2, because then you just measure 4 from the other side, 5.
Yeah.
I mean, is there really any way that wouldn't work?
I don't think so. That's
Gotta
As
be-
long as you had 3 numbers.
That's a good question. Is there, if,
it for that way.
That might be where we're heading.
Oh, sorry.
I don't know.
well, 1, 4, and 5. 1, 4, and 5 might not work. No, because you do 3.
It's between 1
You
and
do
4.
4. Oh, no. Yeah, 1, 4.
Okay, welcome back. Thanks for your deep thinking. That was truly 10 minutes. It went pretty fast, right? Okay, so if you just joined us, welcome. Hopefully Remo is working out for you. It takes a little getting used to, but it's pretty cool. So what I challenged you with, besides senseless trivia about rulers, was this question. If I tell you these are 6-unit rulers, and I delete some markings, are they still just as utilitarian as the original ruler, right? So I don't know if I have the Remo skills, but it would be awesome if someone could join me on stage. Maybe one of my tech friends could help. Does anyone want to come up and share what you found about ruler A or ruler B? Excellent.
Hi.
Hi.
So we found you could find any unit measurements from 0 to 6 with either ruler.
Could you, so wait, you said any measurement from 0 to 6, so we can measure pi?
Any unit measurement.
Oh, okay, good. I was like, whoa.
Yeah.
Um,
Sure.
just
All
like
you need is a circle. You got
Yeah, right.
and a string.
Convince us ruler A can measure 0, 1, 2, 3, 4, 5, and 6 units.
Okay, so 0 and 6 are kind of given on both rulers, since those are like the endpoints. And we can do 1 because it's marked. We can do 2 because we would measure the distance from the from 1 to 3. That would signify 2 units. 3 is marked, so that's given. So 3 to 0. 4 we could do from 1 to 5. That's 4 units. And 5 is given. And there's 6 also on the ruler.
Brilliant.
And so the second one,
Yeah,
kind of similar, from 2 to 3 gives us 1. 2's given, 3's given. 4 is from 2 to 6. So kind of going backwards, we've got 4. 5 is given and 6. So we actually thought that any 3 marks, I believe, I don't have a formal proof, but any 3 marks on the ruler, you could get all 0 through 6 units measured.
That's fascinating. So thank you for your bravery coming up and sharing that.
Thanks.
I love that. And I love you have a conjecture that you're saying any 3 marks, not just 1, 3, 5 or 2, 3, 5.
Yeah.
So that would be cool to play with, right?
Yeah. Yeah. I at first I was like, well, what if you just put them all together, 1, 2, 3? And then I thought about it. I was like, yeah, you could get measuring from the other end.
Right.
But so then I'm wondering about other marks, or maybe are there 3 marks that don't work?
Yeah, I think there's more to explore with just this ruler, and it looks like in the chat others did. Thank you so much.
Yeah. Is there a way to?
I think if you turn you got it. Nice. Okay, so yeah, right on with that analysis. So I guess I was a bit ambiguous, and hopefully you had some negotiation of like, what do we mean by what we can measure? And the idea is you can measure between 2 marks that you have, right? So between 1 and 3, we know is 2 units. But then we can't keep like sliding. We just want to measure between the marks that we have. So still we can't measure 7, or we don't want to like do 2 and then 2 again to get 4. So just between the marks that you have from either end or between marks, we could still get the same measurements, right? So these are perfecter than the original, I think. So some of you already did this, which is great. I want you to see, we always get the length 0 for free, right? And we always get the length of the ruler for free. So what's the least number of marks we need? It was claimed that any 3 marks in a 6-unit ruler could get all our markings. Is that true? Could you get it down to just 1 marking? Or 2 markings? Do any 2 markings work? Once you find the least number, how many different marking schemes are there? Okay, so let's focus. Let's not go to a different length just yet, unless your table has really exhausted these questions. I think there's a lot to explore with 6-unit rulers. So see if you can do it in less marks than 3. If you want to explore, do all 3 marking schemes work? I think there's enough to gnaw on there for a while. Is that cool?
Hello.
Hi.
Okay, so do we think any combination of 3 numbers works?
I think we do. The only one we didn't really think about is 2, 3, and 4. Because we talked about having them all at one end, so that would work for both ends.
Yeah.
And here we have them separated. So the only one we didn't actually explore is 2, 3, and 4. But that works too.
Yep.
Yeah, that works too.
What did you figure out, Kelly?
2, 3, and 4 works. Because you have your 1, your 2, your 3, the 4. Oh, we don't have a 5. 2, 3, and 4 might not work unless somebody can figure out a way to make 5 out of that.
2, 3, and 4.
Yeah.
So that might be good to add in the general chat, because I think there is a conjecture that any 3 marks worked.
How many ways can we do it with only 2 marks?
So I think you could do it. I was thinking about this with 2 and 5. Just 2 and 5.
Yes. And also then 1 and 4.
Yes, which would be the mirror of 2 and 5.
I think what I was thinking before is if you get 2, you get 4, If you get 4, you get 2. It's almost like you can think about those two together.
The mirror symmetries, yeah.
So then you're really just focusing on 3 numbers, making sure you got 4, 3, and 5.
That's true. Yes.
So what does the number of measurements you need have to do with the length of the ruler? What's the correlation there?
Okay, welcome back. I think I visited every table, and you're just crushing this problem. Really cool thinking. Would anyone, I know it's always too short, right? But I think this catch and release is important because we don't want to go just totally off until we understand maybe a smaller case. Okay, so my challenge to you was, we saw that there were 2 ways to do a 3 marking scheme for a 6-unit ruler. And those were better in that they could measure all the original lengths, right? So I'd love if someone could join us up on stage. I think you do that by raising your hand somehow. And one of the tech folks can help you get us up on stage. Or you can share in the chat if that's easier. But not every group was able to hear what your group talked about. So I think a good thing to share would be, what's the least number of marks you determined? And what was that marking scheme?
We reasoned that every measurement you make is a pair of markings. So we could tell something about whether you can get all the measurements by counting how many pairs there are. So for example, on the 6 ruler, if you put down only 1 mark between 0 and 6, now you have 3 marks, including the 0 and the 6. There are only 3 pairs sitting there, so you couldn't possibly get everything from 1 through 6. So that shows that you need at least 2 marks. And as we saw before, 2 marks can do it. In fact, they do it exactly so that no pairing is wasted. That is, every pair gives you a distinct length.
Nice. So I'm hearing you sort of create a boundedness to this argument that whenever we put a mark, we'd like that mark connected with all the other marks to generate new lengths. That way we don't have a redundant measure.
Right.
Awesome. And you said you were able to construct a 2 marking scheme.
Yes, the one that appeared in chat earlier. We had, that was 1 and 4 we made, and someone else in chat earlier made 2 and 5, which of course are the same thing flipped.
Well, yeah, I think that's a great observation. I don't know if all groups saw that symmetry. So maybe let's hear from Jennifer. Thanks, Stephen. That's good stuff.
Thanks.
Can we get Jennifer up here? I think if you turn your camera and mic on, there we go. Great.
Yeah, we came up with the 1 and 4, 2 and 5 also. And then we also came to the conclusion that not all 3 marks will work. You have to have at least a 1 and a 5 in order to get it to work, because you need to get that 5 measurement.
Could you say that again about the 1 and or 5? I think that's important.
Yeah, because in your markings, you have to have at least a 1 or a 5 in order to get the 5 measurement. So I guess you could do, like your 2 examples, A and B, had a 1 or a 5 in it, or both, in order to get that 5 measurement in there. Otherwise, you're going to miss out on that 1 number. So we came to that conclusion.
So a really important word I'm hearing you say or allude to is the notion of symmetry, right?
Right.
Since we really have 2 ends, who cares if we have a 1 or a 5? Both act sort of the same.
Right.
Cool. So then, as Stephen was saying, 1, 4 is effectively the same as 2, 5.
Correct.
Just mirrored over, right?
Yep. Yep.
Sweet. Fantastic. So hopefully we're in agreement that you can't do it just in 1 mark.
Correct. That's
we can do it in 2, and we found 2 different ways. You're welcome to prove those are the only ways. And you also said a 3 marking scheme not all 3 marking schemes work. And you gave what example to that?
You have to have at least a 1 and or a 5 in your 3 mark schemes in order for it to work.
So what are 3 marks that would not possess a 1 nor a 5?
2, 3, 4.
Great.
Yep.
So awesome conjecture. All 3 marks work, but now we have a counterexample to that.
Right.
Great. Thank you, Jennifer. That's awesome.
You're welcome.
So, okay. You've probably been itching for this. Chris, you're slowing us down. This is full exploration now. So I don't know if this is the definition in the literature. In fact, I'll share with you, there's lots of different types of rulers and definitions. So our group just called this a perfect ruler. But let's agree that now let's play with the length of the ruler. So we did a 6-unit ruler. What if we had a length n? So it could be 12, it could be 36, it could be 2 units. Our goal is to have the least marks on that ruler. Of course, you know how long it is to start with, so that you generate all the lengths that that fully marked ruler could have generated. Okay. And to crowdsource our data, I made this not so special spreadsheet, but I thought it would be cool if you find a perfect ruler that you record, where you put your markings. And maybe if you're a different group, you could check if you agree with that, right? We want to keep ourselves accountable. And this is full exploration. So if you have a different question you'd like to explore, feel free to do so. In chat, I'll post the link. Okay, so the exploration I'm suggesting is do what you did for 6, but for other links. Maybe you want to start really small, or maybe you want to go to something bigger. And we'll see if we find any patterns or any structure in this. Okay.
Okay, so I've been working on the 7. And I found multiple ways to do 7 with 3 marks.
Okay. Have you found a way to do 2?
I don't believe so.
And our hypothesis is that 3 we can do, right?
3 with 8, yeah. It would be n over 2 minus 1. Why can't I type in that?
One, 2, 3, 4, 5, 6. I did it in 3 marks.
You did? What 3 marks?
I did. 1,
Okay.
I did it too.
4,
Okay.
and 6.
Yeah, that's what I did too.
1, 4, and 6. Okay, we got 1, 4, and 6 set up right now.
So that tells us 2, 4, and 7 would also work.
2, 4, and 7, right?
Yeah, that's the reciprocal. Yeah. Or the symmetry, whatever.
Yeah.
Whatever you want to call it.
Whatever you want to call it.
All right, I'm setting it up now. Give me a sec. I'm having more fun making the ruler than I am actually doing the math, because that's just a name.
That's okay.
Okay, welcome back. It's incredible that was 30 minutes. And we're ending in 9. So yeah, thanks for your deep thinking with this stuff. Really cool. Actually, I don't want to share that screen, sorry. Let me share the spreadsheet that you were talking through. So look at all this cool data. Isn't this fantastic? So there's no way we're going to be able to debrief all this, right? And if you've ever attended a math circle, I always leave with more questions than answers. It'd be great. Maybe we could hear from 1 or 2 people that just have something really juicy you want to share with others. Do you want to raise your hand if you're such a person with cool info that you want to share? It could be a question maybe that you have as well. It doesn't have to be something you've determined. Anyone want to come up here on the stage with me? Or you're just still entering into the spreadsheet. Let's hear 3's conjecture. Ah, right. Table 3 was Matt and Hiba. Do one of you want to come up? You had a really cool way of thinking about the even length. I think if you turn your camera on and your mic on. There we go.
Yeah. I guess it did turn out to be triangle numbers, but I was thinking you take +1 on the left, and then you take -2 on the right, and then you take +3 on the left, and then -4 on the right.
Could you, would you
meet in the middle?
Would you be willing to demonstrate that? I can pull up that fancy applet that my friend made, and let's maybe try about 12. Could we try a 12 unit?
We can try. I don't know if it works or not.
Okay, we're all friends here, right?
Okay.
Let's see. Sorry, I have so many windows open. Okay, here we go. All right, so here's a 12-unit ruler. And your construction was what? Put a mark at 1.
And then 10, which is a -2.
From the other one.
And then 3, which is a +3.
So go 3 from the end or 3 from the mark we made?
I don't know if it's 3 or 4 at this point. I would try 3.
You're level 6.
Okay,
exactly.
Put a mark at 3.
Yep.
Level I am.
And then I want to subtract 4 from the 12. So I want to click 8.
Yes, just like I did.
But it's giving me a clue to try 7.
Wait.
Can I try 7?
Include both 8 and 7 that work.
Okay.
If we just do 7, it looks like we're missing a length of 8.
How do you
Oh, nice.
it?
I would have picked 8 first, and then I wouldn't know what to do after that.
So you want to sort of like, it's like a volley match back and forth from either end, but work your way into the middle.
Yes. And when we're trying longer lengths, we had to pick the last 2 numbers next to each other, just like the 7 and 8.
Okay.
Oh, so there's one more move we have to make.
I'm gonna do some exercise.
Yes.
So that's something I encourage you to play with. Is there a way to actually construct, something, an actual marking scheme, no matter what length I give you? That would be amazing. The one thing I'm thinking about is from 1 to 3 is a distance of 2, and from 10 to 12 was already a distance of 2. Right? So maybe if we went 1 away, then 2 away, then maybe 3 away from a mark we already have.
Yeah.
Then 4 away from a mark we already have. So then we still get 7.
Right.
But do you need the 6?
Oh, yeah.
Well, that was just going 4 away from the 10.
Yeah.
Oh my god, this.
Look, we did it in 4 marks.
Oh.
There's a 4-mark scheme for 12.
The door, and it was just spamming the
Cool.
door.
I like that teeter-totter technique. I don't know what you want to call it.
I like the volleyball match.
That's cool.
Yeah. Wait, a new trait?
Yeah, I think if you turn your camera off.
I don't know how to do that.
5 arrows.
Oh, there you go. Okay, great. Yeah, so I encourage you to explore this more. Our group basically constructed a similar table, and we also wanted some patterns to exist. And we actually plotted data. We actually even wrote some more code to actually find what we felt was the most efficient. And we didn't really get that far. It sort of looked like a square root curve maybe, or something logarithmic, but that's where we ended up. And technology really helped do the dirty work for us. So I realize we have 3 minutes left. Hopefully you're still into this problem and want to explore it more. I would love to hear from you if you come up with any other determination of ideas or patterns that you saw? So to close, the challenge we always have in our math circle is like, we just want to go on for 4 more hours, right? And it's one thing to communicate virtually and send an email to the group, hey, I found this out, or whatever. But the true challenge we always have is we always like to have a reflection at the end. And clearly I have failed in that regard because we only have 2 minutes left. So I was going to ask you to just consider, maybe take 20 seconds of private think time. What did you find most challenging about this problem? Challenges are good, right? Hopefully you got sort of stuck, but maybe you got unstuck. Subtraction was the hardest. Agreed. Anyone else want to share what you getting your camera to work? Yep, tech. That's not so much about the problem, right? Okay, so maybe tonight or something while you're falling asleep, just think about what are takeaways from this problem. Could you use it in your classroom or with a colleague? What sort of math content is there that's within your curriculum, if you will? Just to give you more things to gnaw on, there are so many other cool like ruler types and definitions. And there's a lot of practicality to this. If I wanted different size conference rooms, this is off Wikipedia, I don't have these graphic skills. If I put notches in ideal places, then I can have lots of flexibility, right? So I could have a conference room of size 2, of size 3, of 4, of 5. The only one missing is 10. Okay, so there's a lot of practicality to this. This isn't just something made up. So I thank you for your time. I encourage you, I'm putting together these problems of the day. They're really meant not only for you to flex your math thinking, but maybe meet someone new and talk through a math problem together. So there's that one today. I made a tiny URL of it. If you want access to this full presentation, here's the link. And I included the article that I mentioned that myself and Raj made that cool applet. There's the article there if you want to read about how we implemented it in our circle. So I thank you for your time. Please stay safe. I'm thinking of all of you, and I appreciate you doing some math with me today. It was a lot of fun. Okay, have a good rest of your day and a good rest of your conference.